everybody. Thank you for logging in to our webinar. We've got Bonnie Nugent hanging out in our chat to help with technical issues. We've got Rich here today to talk about indoor air quality. My name is Christy Olive. I'm a certified industrial hygienist with EnSafe. I've been looking at indoor quality for about 29 years now. So when I run up against a problem where I'm stumped, I call Rich Heisenberger because he's been doing more indoor air quality than I have for that, nearly that length, not quite that length of time. He's a lot younger than I am. We're going to go ahead and get started on our presentation. I'm going to hand things off to Rich to get started, and I'll be jumping in here and there throughout the presentation. Thank you guys so much for coming. Please put your questions in the chat.
Thank you, Christy. Yeah, my name is Rich Heisenberger, certified indoor environmental consultant and safety management specialist with EnSafe. I've been doing this consulting gig for about 20 years, mostly indoor air quality, industrial hygiene, and hazardous materials. That's kind of my wheelhouse, my specialty, if you will. But yeah, thank you for joining us today. This is a topic that I like presenting on. It's fun for me. It's an interesting topic, something we all deal with on a regular basis. So thank you, Christy, for that introduction. And thank you, Bonnie, for assisting with us today. And we'll go ahead and get started here. All right. So today is an introduction to mold and indoor air quality. Indoor air quality means a lot of things to a lot of different people. There are a lot of factors, there are a lot of contributing factors to indoor air quality, such as, temperature, ambient temperature, relative humidity, particulate matter, psychological stress. But really today's goal is to provide a baseline understanding of factors that contribute to IAQ and how to recognize issues and address those issues before they sort of spiral out of control. Our goal is to minimize the impact on our workers' health. So just talking about mold, mold is ubiquitous in nature. It's everywhere. It's indoors, it's outdoors, it's everywhere. It's part of our daily lives. It's in the air we breathe, if we're in our vehicles, whether we're at home, work, outside. And so because of its nature, there are no OSHA or EPA indicator values or published regulated values that say this amount of mold is good, this amount of mold is bad. It's omnipresent, it's everywhere. Unlike lead or asbestos or silica, there are no permissible exposure limits for workers while they're at their occupation. And so we have to approach it a little bit differently than we would something that's regulated, like those three examples I gave: asbestos, silica, or lead. So why is IAQ important? Well, IAQ is important because it's kind of like one of those things where if it's bad, you don't realize it until it's not there, right? Until there's an issue. I think it's something we all take for granted. If we have a space that is, pleasant to us, if we're working at our desk and, we've got the air conditioning, we've got a controlled environment, we're comfortable, that's indoor air quality. That's acceptable indoor air quality. When there's an issue, when something has gone wrong, that's when you realize just how important it really is. Perfect example, this is an actual photo from an office space. I don't think any of us would want to work here, right? You've got, obviously, there's things going on. You've got some ceiling tiles that have fallen in, and this looks like an abandoned office. And that's what it should be. Unfortunately, this is actually an office space that we assessed a few years ago. But moreover, why is indoor air quality important? Well, it's important for many reasons. It's important for the health and well-being of the workers, the occupants. It's important for reducing time away from work, job satisfaction, occupant comfort, focus on your tasks. We've got plenty of work to do, and indoor air quality should not be something that prohibits us from doing our work and our task or impact our health negatively. So what exactly is indoor air quality? Indoor air quality is, as we said before, it's not really defined by OSHA or EPA, but the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE, defines acceptable indoor air quality as air at which there are no known contaminants at harmful concentrations as determined by cognizant authorities, with which a substantial majority, 80% or more, of the people exposed do not express dissatisfaction. So 80% is sort of the goal here. There's an old saying, you can't please everybody all the time. It's hard to create an environment that is comfortable for everybody on the same level. We're all different individuals. We have, different body types and needs, and things that make us comfortable might be different from things that make other people comfortable. So we're going for an overarching goal of 80%, and that's sort of the target that you should have in mind, a substantial majority. And just, hey.
Sorry. Someone in the chat asked a question. Texas still has mold regulations, correct?
Yes, they do. There are several states that have their own mold regulations. That is a state by state thing, for sure. Yeah, and sorry if I misled you there. States operate sort of on their own, but federally, there's, we don't really look to OSHA. OSHA's got some standards and guidelines that we can look to, but there are certain states. Florida's another state. Texas, I believe New York City or New York State has some as well, but really it varies state by state. So that's a great question. You should definitely do a Google search or check with your local Department of Environmental Protection. All right, so we've got some guidelines and IAQ consensus standards that we can look to. ASHRAE standards 55 and 62.1. EPA has the NAAQS, which is more for like outdoor particulates and things of that nature. We don't, in my experience, we lean on that less and look more toward that mold remediation in schools and commercial buildings document. We've also got a indoor air quality in commercial and institutional buildings document by OSHA that we look at, and a lot of that is derived from the ASHRAE standards. So these are all readily available online. You can download PDFs of them. You can actually send away for hard copies. I've got a copy of the EPA mold remediation document, and it's great. Okay, so 80%, right? Keep that in mind. So indoor air should contain fewer contaminants than the outdoor air. Why is that? Well, we've got modern building envelopes that have filtration, HVAC systems, pulling air from outdoors, passing it through filters, it's being conditioned to a temperature and relative humidity and delivered to the service occupied areas. There are also other factors such as air temperature, air speed, humidity, a person's metabolic rate, and a person's clothing insulation. Does everybody dress the same in an office space? Not usually. So those are things to consider. All right, so what if there's an issue? Someone has filed a complaint. There's been some sort of flooding event over the weekend, a pipe burst, or there's been a huge storm, part of the roof fell in. There's suspect mold growth, there's water intrusion. What do you do? These are situations that happen. So We need to be prepared, and we need to be systematic in our approach. The first thing we want to do is, properly conduct an IAQ investigation. We want to handle complaints professionally. We want to perform inspections of the work area. There are tools at our disposal that we can use, such as air sampling, surface sampling, inspection of air handler units, and also review available data and resources. So for a lot of facility managers, human resource personnel, they handle complaints. Somebody's working at an office or a facility, and they're not happy with the indoor environment in some way, shape, or form. So they file a complaint and say, I think the air quality is bad in here.
So Rich, if I have an employee that has lodged a complaint about indoor air quality, and I needed to decide whether to do air sampling or tape lift sampling or some kind of swab sampling, how do I make that decision if I just know that there's a spot of mold on the wall?
That's a great question. We're sort of going to get into that in the following slides, but the key is to handle it professionally and take it seriously. Like I said, not everybody's the same, so what might be good for somebody may not be good for somebody else. But really, once you get that initial complaint or somebody's mentioned that there's an issue, you really have to follow up with it. And the first step there is to interview the employee, find out what's going on, talk to them, look at their work area, look at the area that they sit or their station, look around, what's going on. Really, we're playing Sherlock Holmes here. We're sleuthing around, trying to find clues as to what may be causing issues. Is there an HVAC system nearby? Are there water stains nearby? It's sort of a nuanced approach, a multi-pronged approach. It's rarely just a smoking gun, but it is important to treat the complaint with respect, be courteous, try to get just the facts, and avoid. We want to avoid leading any employee into a direction that we feel, it should go. And most importantly, we're not there to judge. We're just there to collect just the facts. So just keep that in mind, be objective in your approach. And like I said, once you've interviewed the employee, the next step is to sort of follow up with documentation, look around, take notes. What do you see in the work area? What don't you see? Are there odors nearby? If you've got instruments at your disposal, you can take readings, find out what the temperature looks like, take photos, document everything. Inspect the employee's work area. Again, just looking for any clues, visible water stains. Is the housekeeping good? I can't tell you how many facilities I've been in where it's just every room seems to just be cluttered. And clutter is usually bad for the indoor environment. It can lead to debris accumulations and poor housekeeping. Boxes that get stacked up, in an office tend to not get moved or cleaned behind very often. So they could be concealing something. It's really your job as someone who's receiving these complaints and handling them to address them. Are there mechanical rooms nearby? Break rooms or restrooms nearby? And you can really, dive in here and really get into the details of a facility. There are building pressure relationships that matter. Usually a building is positively pressurized, meaning the HVAC system sort of works to prevent the infiltration of unfiltered air into the building. So usually when you open the door to a facility, you should feel sort of a puff of air that positive pressure. And likewise, there are parts of a building that are under negative pressure. Restrooms, especially under a negative pressure, usually they're exhausted out through the roof. For obvious reasons, you don't want, bathroom odors sort of finding their way into work areas. So there are a lot of things at play here. There could be printers and copiers nearby that contribute to particulate in the air. Don't see that too often, but really it's a documentation process where you're looking at all these factors and sort of taking all these pieces and sort of trying to build the narrative. You're putting the puzzle together. You're trying to figure out what's going on. I'm sure most of us have seen this scenario before. You've got water stains on ceiling tile, and left untreated, those can turn into, they can go basically from the photo on the right to the photo on the left, where you've got some suspect mold growth there. You can see in that right-hand picture that there's a sprinkler head right there. So that's a clue that maybe there's a pipe that's leaking, or it could be any number of things, but really, that's a clue right there. That's something you document. You can pop your head above the ceiling tile and take a look around, see what you see. You can document that. Are there sprinkler pipes up there? Do you see active drips? Is there daylight coming from the roof deck above that area? Maybe it's a roof leak. Other things could be HVAC ducting, condensation drip pans that are located above the ceiling. So a lot of factors. Really, you're documenting, you're taking pictures, you're looking around. Here's another example here of some blistered paint. Obviously, there's some in that photo on the left, looks like some windowsill issues there. Maybe it's not caulked properly on the outside, but I can only imagine what that drywall looks like underneath that painted surface. It's probably not pretty. Okay, wallpaper and mold, a love story. I guess, and Christy, feel free to jump in here, but I don't know how much we see wallpaper anymore, really. It seems to be a trend of the past, interior finish wise, but it can really just be a breeding ground for mold and contain moisture. And honestly, it's the perfect breeding ground.
You do see it a lot in state and federal buildings where they were last decorated in the 80s when wallpaper was huge, and they just haven't had any budget to redo those since then. I had a hotel in Alabama with a mold problem, and it was legacy. They had put up wallpaper many years ago. It was a nice neutral color, so they hadn't felt the need to redecorate. So you do see this sometimes. So if you walk into a room and it's painted, also you want to look and make sure that it's not painted wallpaper, because that's what they had done in this hotel. It was like when they started to knock down drywall to expand some of the rooms. All of a sudden, as soon as they slung the first sledgehammer, we find out that there's wallpaper, because the wallpaper starts hanging off, and then there's mold behind the wallpaper. So
Sure.
it's something to keep in mind. If you got any building that was built in the 80s or even the 90s, we were still using a lot of wallpaper. So older buildings that haven't been redecorated, you still run into this some.
Yeah, and really that photo on the left, it looks like somebody sort of peeled back a corner. Maybe there was a corner showing, and then they peeled it back even more. I would, if you have a situation where you've got wallpaper and you can see behind it and you can just tell that there's some discoloration there, there's some suspect mold growth, pulling that wallpaper away is probably not a great idea, right? that should be handled by a remediation company for sure. Because if you pull that wallpaper away, all you're doing is potentially making all of that suspect mold airborne. And that looks, I mean, that looks nasty. At least when it's behind the wallpaper, it's somewhat contained, it's somewhat encapsulated. But I would caution anybody trying to investigate that any further. I would sort of just leave it at, we know there's an issue, get some professionals in to take some readings and go from there. So moisture meters, great tool to sort of locate water intrusion, look at porous building materials such as drywall and ceiling tile. Drywall is ceiling tile sort of shows, it's a little more visible when there's a water intrusion or something going on because you can see it. Drywall is less, you can't really tell all the time just by looking at drywall. Sometimes it's blistered up, or you might see a delaminating drywall seam where the tape is sort of visible. But a moisture meter can be a great tool. Most moisture meters have a pin mode, which is more accurate, and it uses electricity to conduct. So the theory is that the moisture content of the drywall would conduct electricity from probe to probe and sort of gives you a reading. A lot of them also have scan modes, which are less invasive, but they can also be a little bit less accurate. And things like metal conduit or metal building studs can sort of throw off a scan with a moisture meter. Also, thermal imaging cameras or IR cameras are a great tool also for sort of demarcating where some intrusion might be happening. You got to be careful with the IR camera because moisture intrusion tends to show up as like a cool spot, so cool areas. But you could be pointing, like these photos here. They're likely, especially that one on the top, it looks like there's some moisture intrusion happening at the floor level. But above it, the shot of the ceiling, or the lower picture, sorry, that could be a air conditioning vent that's hitting that area. So really, moisture meter is good, but you're sort of indiscriminately poking and prodding and scanning around. Thermal imaging camera is good, gives you some good data. Really what you want to do is use them in tandem. I mean, they're great. You can sort of scan through a building with the IR camera and get an idea of where you want to take your moisture readings. That I found is a really great approach. Okay, so on to air handling units and HVAC systems. These are called systems because there's many components. You've got ducts, you've got fan blades, you've got fan housing and coils, air filters, condensation pans, and they all sort of work together to keep us comfortable at our desks or in our facility. The trouble is, any one of these components can sort of go bad or have an issue, and it causes trouble, in our offices or in our facility. So here's a pretty simplified explanation of how an air handling unit works. Most commercial air handlers, they mix return air with outdoor air. It passes through filters, it's heated and cooled or conditioned, and it's delivered to the service occupied area as supplied air or conditioned air. There's many different configurations, different types of air handling units. Sometimes they're located on rooftops, sometimes they're in mechanical closets, sometimes they're in basements. They can be above ceiling tile. Really, it's all dependent on your facility, when it was built, and how it was designed. Here's another more simplified version. Now, sometimes you can have what is called a return air plenum, which is tends to be like a space above a ceiling tile, or the space above a suspended ceiling, where the whole space is basically the return. So it doesn't operate on ducts like it does for the supply. For the supplied air is ducted. Usually a return air plenum, like the building I'm in right now, actually uses a return air plenum. If you pop a ceiling tile and sort of look around, you'll see that the whole space, and you can sort of feel it too. Once you get up there, you can feel the air movement. But that's, different facilities have different setups. Here's a very large rooftop unit. And there are all types of different air handling units. This is just one example. This is I believe this is a unit that was used for a medical facility or a lab, where it used 100% outside air. It did not recycle any air. There was no return air. Very large industrial unit. These tend to be obviously more complex and harder to assess. You can see there's sort of man doors on the side where you can walk in and look at the filter banks, dozens of filters in these things. Very complex machines. And of course, once we access an air handling unit, hopefully we're doing that while it's powered down. I don't recommend accessing any HVAC unit while it's running or while it's energized. So lock it out, tag it out, have maintenance personnel open it up, look inside, and you can usually tell just visually what's going on. You can see things like that top picture. You've got rust. That tells me that there's standing water in that pan and it's not draining. So maybe the drain is clogged. Maybe there's something else going on. The coils could be frozen over and causing excess water. Is there visible dust and debris? Are the fan blades visibly dirty? These are all things you can look for. Look at the filters. Are they properly installed? Are they the correct filters? When's the last time they were changed? All these things sort of, are pieces of the puzzle. So when you're looking in an AHU or HVAC system, be mindful that there's a lot of components, and make sure you take good notes, good pictures. Again, here's some preventative maintenance tips for air handling units. Really they need to be physically cleaned on a regular basis. We would recommend that you follow manufacturer's guidelines for that, or as needed. But that includes, the physical cleaning of things like fan blades, coils, fan housing, condensation pans. Sometimes condensation pans have a conditioning additive that's put in there by maintenance personnel, and basically that conditions the water and helps it drain easier. So you can also look at things like how often are the diffusers and return grills cleaned. I think we've all probably seen an office building that's maybe a little bit older, doesn't look great, not taken care of very well, with the supply vents and return grills sort of covered in like debris, electrostatically charged particles that just need to be cleaned. And these activities should occur at appropriate frequencies. So we reduce those conditions. Really, that's what we're looking at. Appropriate frequencies so that we're, reducing the conditions that may negatively impact the indoor air quality. Okay, so moving on to some sampling equipment. We've looked at our workers area. We've done the visual assessment. We've looked at the HVAC system. What are some other tools that we can use to document what's going on? Well, this piece of equipment here pictured is a TSI Q track. It's also called you can use a VelociCalc there are different probes that you can use. But that's a good way to measure some parameters that you may find useful when assessing the indoor environment. Things like temperature, relative humidity, carbon monoxide, carbon dioxide. Carbon dioxide is something we look at as a surrogate of good ventilation. If you've got more carbon dioxide inside of a building, if you got people complaining of headaches, that could be a symptom of not enough fresh air being delivered. Or, there are louvers on a rooftop unit that allow outdoor air to sort of mix in, things like that. So these are all data points that you can use to assess the indoor situation. You can also do some air sampling. That's something we do actually pretty frequently when we do assessments. We'll use, media. There's different media that you can use. Spore traps are sort of the industry standard right now. It used to be Anderson samplers and sort of petri dish plates that you would collect air on and then send them off for culture, and they would sit and sort of grow, and you'd see what viable things were in the air. But mostly for the most part, we're using spore traps, and they collect viable and non-viable particles, and they just basically draw the air in and impact any particles on like a adhesive strip in the cassette. You can also use smoke tubes to do your building pressurization assessment. Talked about that a little bit. Again, it's a nuanced approach, multi-pronged approach.
Rich, can you address why we might choose to use a tape lift over a swab or a spore trap?
Sure. Tape lifts are handy. Swabs are handy if you really need to know, what kind of debris you're looking at. If you've got, somebody who's sensitive to a specific type of mold, you can really narrow it down with a direct examination of a tape lift or a swab. Swabs are also used for, if you've got like a sewage backup or a flood situation, you can swab thresholds of doors or areas that have flooded for sort of like E. coli and other total coliform analysis, just to see what's going on if you've got sewage backup. Mostly we use tape lifts for surface samples. This is just one guy's opinion. I don't know how valuable they are, but if you've got growing mold on a surface, you've got to deal with it regardless of what it is. So if you really want to sample it, by all means, take a tape lift, take a swab, send it to the lab, and they'll tell you what it is. Likewise with spore traps, they're great for assessing the indoor air of a space. You can get a pretty quick turnaround with a spore trap. As I said, the Anderson culturable samples, which are more costly and they tend to be like a longer turnaround. The spore traps sort of give you a quick snapshot of what's going on in that air when you collect that sample. Now you don't have to use one of these. This is just an example of a biopump sampler, and something like this would pull air at 15 liters a minute. You could also use like a rotary vane pump if you've got just a pump that might be used for other air monitoring purposes. but you're basically taking that systematic approach. You're collecting a timed sample for a documented volume of air and submitting it to the laboratory. Here's a little illustration of surface sampling equipment. You got a biotape, tape lift, got a swab. All these techniques really are tools in your toolkit. You collect the sample, you document how long you collected the sample or the area of the sample. If it's a tape lift, it's usually 1 inch square, or if it's a swab, you can swab a templated area and send that to the lab. You complete your chain of custody, all the documentation. Here you go. Here's what it looks like to collect a tape lift surface sample. Swab sample. And really, it's important to, prevent contamination between samples. So would recommend, if you're out there pulling samples, use nitrile gloves, cap the samples immediately, label them, put them in a baggie, and then complete the chain of custody, ship them to the lab. And really that's the approach. In addition to sampling, you do your visual investigation, you can do your environmental monitoring, your building pressurization. You're putting the puzzle together. What is going on? You sort of, once you have all your data, that's when you can really sort of make your plan of action.
Something I learned the hard way on that was that all of those inside of each one of those aerosol cassettes is a little glass slide. And so you want to handle those carefully and pack them carefully when you ship them to the lab, because if they break, they cannot analyze them. And I had one, out of the dozens and dozens that I've pulled, I had one that where FedEx had thrown the package down and I didn't have it wrapped in bubble wrap, and that little slide broke. And so we weren't able to get a result on that one. So it's just something to keep in mind, that there is a little glass slide inside those aerosols.
Yeah, great point. Great point. Pack them good. All right, so you've completed your assessment. There's been a complaint, you're addressing it, but other employees are sort of, noticing something's going on, something's been said. There's some sort of issue at work in our facility, and they're going to naturally have questions, and they're going to be good questions. People are informed. They understand things more than maybe, somebody in a management position might give them credit for, but it's important that we handle any questions properly. And of course, always remain professional. It's
All right.
Yeah, Christy, if you want to speak to this, feel free.
Okay, I'm going to jump in here. So this is what I mostly did for all the years that I worked at my last job. I was responsible for coordinating those complaints. I would get a work order, or I would get an angry phone call and someone would say, there's mold in my office. I watch late night TV. I've got the internet. I know that it's toxic black mold. It's bad for you. And this must be toxic black mold because it's black. And so I'm going to die if you don't come and fix this immediately. So the first thing that you have to do is exactly what Rich said. You've got to remain professional, because regardless of whether this person called you yesterday to complain because they didn't like the odor of the disinfectant we're using in the bathroom, and they called a week ago to complain because one of their coworkers wears too much perfume, you've got to leave all that out of it, because now it's an indoor air quality issue, which means that there's some legal liability involved. So you got to take it as an isolated incident. And regardless of your history with that employee or with that customer, you've got to treat this alone. So the main thing is you tell the truth. What is the truth? So I walk into the room and there is some substance on their ceiling or on their wall or on their register. Well, since mold is ubiquitous in the atmosphere, then yes, it could be mold. So I'm never going to say no, that's not mold. The predecessor where I worked at that job, that was her approach. She would say, no, that's not mold. So you want to tell the truth. I can't tell. There's probably some, it could be just garden variety dirt, dog hair, but it could be mold. So we're going to take a sample and we're going to determine what we have. We're not as worried about whether what's on your register is the problem as what's in the air you're actually breathing. So you want to tell the truth. You want to tell them, hey, this is where we are. This is the process at our facility to handle that. So the process at my facility was to follow the EPA guidelines, which was that if it was less than 10 square feet of surface contamination, we might handle that in-house with our trained persons that were trained inside. However, if it was any more than 10 square feet visible, then we were immediately going to get an indoor air quality assessment by a third party, because we don't want those things to influence. We don't want the fact that the person reported this is a habitual reporter of hazards to influence us in whether or not this is a real hazard. Same thing, we have someone report to us that has never reported anything before. Well, we still have to investigate whether it's a valid concern, even though this is a person we trust. We know they wouldn't complain unless they had a real problem. So we want to be professional. We want to be unbiased. So we want to tell them the truth. I can't really tell by looking with my eye whether that's Staphylococcus or Aspergillus or some other kind of mold. But what we're going to do is we're going to address it for you. We're going to take a sample. You want to be sure that you have interviewed the employee, like Rich said, and as you're talking to them, be sure that you validate their concern. I see what you're saying. I would be concerned too. Here's how I'm going to handle that. Make sure that you redirect questions if you're unsure. It's always fine when they say, is that mold, to say, I don't know. I can't tell by looking at it. I'm going to have to get someone else in to look at that for me. I don't know whether we can handle that in-house. I'm going to have to speak with our maintenance personnel and find out. So you want to tell the truth. Never say we'll have this fixed tomorrow if you have no idea when you're going to have it fixed. We'll get that fixed for you right away. In their mind may mean that this is going to be fixed by after lunch. So now when you get it fixed tomorrow, you drug your feet on it. So tell the truth. I'm going to have to get someone in here. That's going to take a little while. Do you feel comfortable staying in this space in the meantime? And then according to your HR policies and your supervision and management rules, you may be able to relocate that person until we can determine what the problem is. And your workplace may not allow you that, but tell the truth. Just tell them the truth. Don't ever overcommit early on, because then the next time you talk to them, you're a liar. You told me you'd take care of this right away, and it's been 2 hours and you haven't taken care of it. So be sure that you tell them the truth. Be sure that you inform them about a time frame and that you're honest about those time frames. So if you know that it's going to take you a couple of days to get someone in from the outside to look at this, it's going to take another few days for us to get back any lab results. And then we'll still have to get funding approved to fix the Be honest about that. This is going to be an extended period of time. Manage expectations early, so that people they're already angry because their office space is not what they expect it to be. So at least start to establish trust early on. You want to redirect their questions when they're not sure, and you won't be sure on a lot of things with mold. It is not like asbestos, where we say, okay, well, that material has asbestos in it, therefore we know it's more than 1%, we have to abate it. We're going to have to do some tests, and some judgment calls may have to be made. Avoid giving your opinion. The biggest one is somebody walks in and they say, I wouldn't be worried about this. I'd work in here. Well, okay, but your tolerance for it may be completely different. This person could be on immunosuppressive therapy. This person could have severe allergies. This person could be going home to a child or a senior that they are the caregiver for that has those conditions. So avoid giving your opinion. Avoid saying, everything's probably okay. And then once you have data, you base your conclusions on data. You don't want to give opinions. You want to be honest. You don't want to alarm people. And you want to be forthright with your conclusions are based on data. So that is the good thing about mold, is that, we do have the ability to professionally obtain third-party data. So I had a daycare facility that I was working with some time ago, and they had a room that had some kind of surface contamination. First of all, these are all very smart people. They were teachers. They were preschool teachers. They are used to wanting to take care of people, wanting to do the right thing, and they're very educated and they read up on everything. So there's no going in here and saying, hey, that's not really an issue. You know, don't worry about it. We'll paint it and it'll be fine, because they can go on the internet and look up everything we can. So the first thing you do is you come in and you say, okay, I see your problem. This is how we're going to address it. Here's a timetable for how we're going to address it. I find that people respond very well to timetables in that setting, because they know there's a problem already. So they just want to know, how long am I going to have to deal with this problem before it's solved, to the degree that you can. Keep all your equipment and paperwork readily available. You want to make sure that if somebody asks that question, somebody comes in this week and hires in, and they hear from their coworkers that you did a big mold cleanup last week, and they're wanting to know how we know that it's been cleaned up. If you have paperwork that shows that you did an abatement and it is complete, you want to have that available, readily available, so that you could show it to people and discuss with them how you addressed it the last time and what you would do if it ever happened again. Make sure that all findings are documented thoroughly, and ensure that when you are collecting samples, you want to either have that training yourself or use a third party that has that training, so that the samples will be collected properly. They'll be shipped properly under a chain of custody. They will not be cross-contaminated, and that the data you get is actually valid data. In the case of the daycare facility, obviously they were not just concerned for themselves, but for these small children they've been charged with taking care of. So I sat down with them when we got the report back from the third party, and I said, we're going to start with this report at the back. We're going to talk about all this data at the back and this catalog where it tells you all the different kinds of mold and what their hazards are. This is a reference document that the company has included to help you learn more, but you don't have all of these types of mold in this particular case for this particular report. It's important to tell them that. Otherwise, they're going to open that back page and see that there's 50 types of mold listed, and they're going to think they've got all those. So we always start at the back. This is an appendix. This is a glossary, if you will, that tells you all the different kinds of mold. So we started there. Then we went back to the front and we started through. We did this assessment on this date, and this reflects what happened on that date. Here's the results that we got, and here are the recommendations that the company has made for what we need to do to address that. So one thing that we had to do at that place of employment was we had to have 3 quotes every time we did any kind of mold remediation. So in order to do that, you have to make sure everyone's bidding on the same scope. So if you want a bidding protocol or a scope of work to be part of that indoor air quality report, you need to request that when you request your indoor air quality report. Because some companies that do remediation won't work without a third-party protocol. So if you request that third-party protocol, you've got it, then you can get an appropriate bid on. You don't want everybody bidding on apples and oranges when you're talking about mold remediation. And you want to set what you want your final clearance criteria to be. When you're setting out that RFP, you want to make sure you know what your final clearance criteria is going to be, because what they don't want to do is give you a lump sum and then have an open-ended job that lasts for 3 years. And what you don't want is a time and materials job that's open-ended and lasts for 3 years. So you want to be sure that you're communicating well with your remediators, that they're licensed under your local government, whether that be state, federal, or city. Where I was, they had to be city. So you want to be sure that you're communicating with everyone. When you sit down and look at that lab report, it's going to come to you and it's going to list several types of mold species. So you got these Alternia, ascospores, basidiospores, Colvaria, and you're going to go all the way down through here, and then they're going to go, I heard on late night TV that Stachybotrys will kill me. So Stachybotrys is going to stand out because they're going to look up these and they're going to know that this one's got more press than the others. Just because it's Stachybotrys doesn't mean it's necessarily the only problem that we have here. There are certain species that are indicators of a continuing moisture problem. And Stachybotrys is one of those, but it's not the only one. So when we're looking at these reports, we don't want to say, oh, there were 0 Stachybotrys so we don't have a problem. We need to look at all the species and see if there's a problem. The other thing that we look at commonly is we're going to collect those indoor samples and those outdoor samples. And we're looking to make sure that we don't have species indoors that don't occur outdoors, because normally, simplified version of how indoor ventilation works, we have air outside and it gets brought inside through a filtration system. So if we have a species outside and it comes inside, then we would expect that there could be some, but there should be less of it. However, if we have a species inside and it doesn't exist outside, then it must be growing somewhere inside our facility. So that's another thing we look at. We look at the species that are present inside versus outside, as well as the quantities, to determine whether this is a problem with our HVAC system, whether this is a problem with our building envelope, or is this a moisture, is moisture the main source of our problem? I'm going to hand it back to Rich. Anything else you want to say about the species?
That's a great summation, Christy. I think, and we talked about this early in the presentation, that really you should have similar biodiversity inside compared to outdoor samples, but in lower concentrations inside. And that's because of things like filtration, modern air handler systems with filters. But you're right, there are certain organisms, species that we look at as indicator species for chronic moisture. We also look at the total concentration of spores from each sample location and compare those to what we see outdoors. Okay, so results are in and there is a legitimate IAQ issue. What do we do? What are the next steps? We have to address it in the sake of people's health and well-being. So we take the appropriate measures, and more often than not, we talk to the employee. Can that employee or employees that are in that affected area, can they be relocated to a non-affected area? Hate to use out of sight, out of mind, but usually if you are sitting in an area that's got chronic issues and you're looking at it every day, you're very acutely aware of what is going on. So by moving an individual to an area with no issues, that helps to alleviate that employee's psychological stress. But we've also got to address the issues at hand, and we can't really do that with people still sitting at their desks in the affected area. As we said before, control the water, control the mold. We need to target the sources of water intrusion. Could be condensation above the ceiling tile, could be a broken pipe or a valve. It could be overspray from an irrigation system. That picture on the left, those sprinklers are getting that wall pretty good. What's on the other side of that wall? Well, there could be an issue there. Okay, so we've got an issue, we've got some mold, we've got some porous building materials. Can we just grip and rip and tear everything out? Of course not. We've got other considerations here, other hazardous or potentially hazardous materials, including asbestos and lead-based paint, among others. If there's a leaky pipe, is it covered in pipe insulation that's got asbestos? Is that windowsill that we need to remediate, is it covered in lead-based paint? These are things we need to find out before disturbing any materials. So in order to not make a bad situation worse, it's important to address potentially other hazardous materials by a licensed professional. And you may be looking at performing an abatement in addition to a mold remediation, which honestly is a great time to do both, because you're disturbing the material. If it's an opportunity to get some asbestos out of the building to facilitate the remediation, you're going to be in that area anyway. It's going to be under a work area containment. It might be advantageous to do it all at once. And there are insurance implications and there may be cost benefits to doing those in tandem. So utilize the EPA document. This is a great document. It's available on the website. It's more of a pamphlet. It's like 50 pages long. And it really breaks down step-by-step instructions for handling mold remediation situations. Different types of water. Is it clean water? Are the materials affected? Are they porous? Are they resilient? Sort of gives you a guide on how to deal with remediating any mold issues. If it's a small job, it may be able to be handled internally by maintenance personnel who are trained. It gives a step-by-step of proper PPE and engineering controls. If it's a larger, more complex job, I would of course recommend an experienced mold remediation contractor. They've got the means to handle it properly using engineering controls, HEPA filtration. They can take care of a mold situation. That's their job. That's what they do. So once you've got that far, once you've remediated the issue, we would recommend some follow-up sampling, some more air sampling, some more documentation, visual inspection, and really that is to document the efficacy of what you did, your response action. Is it cleaned up? I mean, a lot of times we'll do some sampling in a post-remediation situation and we get some air results back and it's not good. It's not clean. So we would have them re-clean the area and pull additional samples. And basically you want to get to a point where you're seeing that similar biodiversity in the samples outside to inside, but in fewer concentrations. And once you've done that, you want to monitor the situation. Keep an eye on areas that were remediated. Watch for new instances of water intrusion and document preventative maintenance and housekeeping schedules. Talk to your employees, really get their input and make good faith efforts to improve the indoor environment. And that goes a long way, that good faith. All right. So we're about toward the end here.
One thing, as you're using the instrumentation, if you're going to go out and actually do the indoor air quality survey, Rich, how do you decide how many samples to take or where to take them if you were the person doing the survey?
Great question. Number of samples is sort of, I go by square footage, layout of the facility, but I would definitely target the bad area, the area of the complaint, the area around that particular area, and then also some non-complaint or control areas. Get an area of the building that nobody seems to have any issues with. And of course, you're going to want to get at least a couple of outdoor samples to compare those two. Great question.
How do you recommend talking to someone about if they are just very focused in? I've had employees in the past that have been just very focused in on, is it black mold? Do you have any recommendations for how we can talk to them about the different species of mold or anything like that?
Yeah, so that term black mold gets thrown around a lot, especially media channels and stuff. But really, we don't know what mold is until we get a lab report stating exactly what they found, and we can't speak to a person's sensitivity to that species of mold. So my advice would be to be honest, talk about your approach. Here's what we're going to do. We're going to sample. We're going to find out what it is. It does affect some people differently than others. It's not necessarily toxic for everybody, or at least on the same level. So just being honest and just the facts, just be in lockstep with the employee, sort of walk them through what your approach is going to be, and just say, we'll see what it is, and we'll make an appropriate determination what to do after we get the results back. Another good
Okay,
question.
we have a question from the chat. Is it required to have a written policy for companies to follow in the event they're audited by local, state, or federal agencies?
To my knowledge, there is no requirement to have a mold plan. However, if there is an old facility, if the facility is of a certain age, you would be required to have a hazardous materials or an O&M plan for asbestos containing materials. I would say that it's a great practice to have some sort of mold response written program. I'll have to dig deeper for that one. I don't want to speak out of turn here, but to my knowledge, there's nothing required. It's always best practice to have a plan for different hazards that could be at the workplace. So I would say it's a good idea. I don't know if it's a requirement.
Yeah, I agree. I'm not familiar with the requirement at any rate. Okay, if are there other questions? Okay, Michael asks, how does one report when there were no identifiable factors during the survey? So if they walk in and everything looks okay, but the people are still concerned, how would you report that?
That happens very often. So that's sort of the multi-pronged approach, right? It's not usually a single smoking gun issue, in my experience anyway, doing assessments. I would just document the heck out of everything you see, everything you don't see. Issues can be, perception's reality, but sometimes issues can be perceived and they're not really there. You can document what you don't see as well as what you see. If you're taking readings and you're taking samples and everything looks good, seems to be within the recommended ranges, spore concentrations look good, it's important to document that as well and present it as data to the employee who's concerned. And that's really all you can do, is just document it and keep looking for other sources. Look for printers in the area or mechanical rooms or building pressure relationships. But really, if you've done your due diligence, and it's all about due diligence and good faith, if you've put forth the effort to address the complaint, take it seriously, follow up, do sampling, and if there's nothing to be seen, then you're really left with just monitoring the situation and looking for changes that might negatively impact that one way or the other.
All right, thanks, Rich.
Yeah. This was fun.
Yeah.
Appreciate everybody joining.
Yeah, thank you so much for taking the time to join. If you have other questions that come up later and Rich is displaying our email, feel free to email us. Or if you just have a question that you don't want to put out here in the recording area, feel free to email us and ask that question, and we'll get back with you with the best answer we have. And we have other resources at EnSafe. If Rich and I don't know the answer, we have other people we can reach out to and find answers for you.
Great. Thanks, everybody.
Thank you, everyone.
Rest of your day.